So this video is for kind of technical engineers. I mean, I guess you can watch it and find it entertaining, but this is how to rebuild and clean the entire TQ Absolute. So this is the basically a very high-end instructional guide from like the best in the West. This is like the best engineer that takes these things apart, cleans them, and puts them back together. Everybody in biotech sector and agricultural sector, everybody who uses these quantitation triple quad instruments from Waters that has the newest, the latest, and the greatest, the TQ Absolute. This is an instructional tutorial from the engineer. I'm filming and narrating a little bit. It's about 38 minutes long. It shows the complete disassembly, and then I tried to get as much as I could on the assembly and put back together. But you can rewatch things in reverse and figure that out. But all the tips and tricks on how to clean the source block, the StepWave, pulling everything out, taking every single piece out, sonicating it and cleaning it, taking the entire quad assembly, cleaning the front and back quadrupoles and the collision cell, and taking the whole collision cell apart. And so this is if your instrument does not have good signal, this is the guide to fix that, especially if you're having charging or if you have the effect of signal decrease over the length of a run that's brought back when you switch polarities from positive to negative mode really quickly. If you do that and your signal kind of comes back for a little bit, you probably just have charging from a dirty quadrupole, and we'll even show what it kind of looks like. It's so hard to see on the lens. So enjoy some really high-end technical content. And again, it's shot in vertical format because it's designed for engineers that are like holding a phone in one hand and doing stuff with the other hand. So this is the reason I shoot in this vertical format. It's just easier in the lab when you're using it. All right, enjoy. Got this, it's a TQ Absolute.
It is.
It's the new triple quad. Just took the source enclosure off. That's easy to do. And now we got that front source block. So the first thing's going to be removing the ion block and taking all the little O-rings out and things like that to get that sonicated and cleaning, and then we're going to get deeper into the instrument from there. All right, so, piece of cake, just 4 screws. They counter...
2.5 millimeter.
Are they countersunk?
No, they're captive, but usually when you sonicate it, they'll come out. So
okay.
Put them right back in.
And then this is what it looks like.
Do you guys have the little tool for extracting the
We do have the tool. Special tool to take out the StepWave.
This is just a convenient thing. It slides in. It makes it easier to get back. This is the real deal right here because it allows you to align the StepWave perfectly when you're putting it back in and seat it the correct distance. If you don't seat it the correct distance, you'll see a vacuum leak error.
Gotcha. And it has to be this like tiny little bit out.
Yeah, it pretty much always is, right? The source, because basically you've got this little recessed area right here. So this is the equivalent of the extraction cone that you see on that instrument. This one doesn't have an extraction cone, but that's basically the equivalent. So
it's right in contact, and it kind of probably pushes on it a little bit, so it seals.
It just sits right in front of it.
And that's why it's got that interesting shape.
Yep.
And then those pogo pins right there. Those pogo pins right there, you can always double check to make sure those are making good contact.
Leave in place, pull this out, clean the center of the isolation valve, and then pull the heater out and all that kind of stuff.
And then you can put the whole thing into the sonic header, right?
You got it. And normally what I'll do for this...
So just, again, a couple screws, 4 screws. Just careful to slide this out, and now you got... That's the pogo pins for the heater assembly, and there's the StepWave we've got to pull out.
It comes out, you just basically tuck it under and pop it.
Like a bottle cap.
You got it.
And then you put the liner on there.
Right over that. I mean, it's just
and
like
it just notches right in, and then that gives you protection when you slide the whole thing out.
Yep.
And then it's kind of just sitting here. And then now you can just slide it out into the StepWave.
So this is very similar to the... Is that a G2S?
XS.
S. So it will have the StepWave.
Yep.
It has the predecessor to this.
Yep.
The front end will look somewhat similar, although this one is the one they call the Snowman.
Yeah, because of the shape.
Right, exactly.
No longer a
This one
circle.
has the snowman one. That one will have just the round circle. Yep, exactly.
Yep.
And then the back end of this one is not a twig. That one is a twig. This one is a segmented quad.
Gotcha.
Basically, so it does a better job of focusing, at least in theory.
So one thing that
A little bit of wiggle.
A little bit of wiggle is normal.
When it's connected is normal,
Yes,
so don't
sir.
be alarmed.
Yep.
And it kind of, when it slides into this assembly, it just kind of straightens it out properly.
Yes. Correct. It aligns everything once it
And
gets
so
in
then we're
there.
going to take these two pieces apart.
Yep.
Again with the 2.5.
This is. Somebody went ham on that.
Yeah, don't over tighten those screws, guys.
Don't over tighten. Yeah. Snug is good.
But it is like, you know, circuit board here.
And all those screws are hollow. Make sure that that's the case.
Okay, so nothing in the screws, hollowed screws.
Yep. Keeps you from having outgassing.
That's smart.
Somebody was using their noodle.
Go. Yeah, I know, right?
Happens on occasion.
It's super cool that you have hollow screws for outgassing.
Yeah.
Yep, and there we go.
A little burn, not too
A
bad.
little burn in the center
Little
of the
burn in the-
StepWave
yeah,
there,
in the,
and then all
that
you did is take out that little insulator plate
so basically
there.
that just this
Sits
will
on
align incidentally.
Gotcha.
So if it doesn't align with this,
Gotcha, so it drops in there and then aligns properly.
You can flip it over and it won't work correctly.
Gotcha, so there's an
make sure
orientation.
make sure that little bull nose there is fitted correctly against
Gotcha,
the
so
outlet.
you kind of have like a rounded taper there.
Right.
And that tiny little bullnose is out.
You got
so you
it.
have that plate in the right orientation.
Yeah,
But it won't fit right if it's not the right way. So.
The thing is, it will go.
Oh, it will go.
But
And it does
won't-
have the same divots.
Right,
But it
you'll
just
see
you'll see there's a gap.
that's no go right
That's
there.
bad.
And it will not work.
Won't work that way.
Don't ask me how I know that.
All right.
Disconnect.
Okay, so then just right on in there.
Be careful when you're reinserting this, and I'll show you that when we get to that point. But be careful
Okay,
when
so
you're
that's just a
reinserting that.
screw with an insulator around
You
it
got
there.
Yep,
These are pretty long screws, so
they are, and they're easy to strip.
yes, take your time.
So when you put them back in, I'll show you right now. So when you're putting them back in,
You want to make sure the alignment's right.
So
right?
what you want to do is go backwards and hold the rod.
Okay.
Go backwards until you feel a thump.
Gotcha.
There it is. And then you
Gotcha.
go right in.
So
Otherwise
you'll
cross-thread it.
cross-thread it. Yeah. So that's a smart tip when you're trying to not cross those things. Actually, go the wrong direction
Yes.
first until the threads line up.
Yes.
Then go the
You'll
proper
hear the
direction.
thread actually go plunk
Plunk
as it
down
drops
in.
in.
Yep. Smart.
And that works out very well. Yeah, this needs to be okay. And the tricky part about this, you've got all these contacts in here for
Yeah.
these little, because you got pogo pins that make contact with
Oh,
this
my goodness,
when it goes
yeah.
back in. So you have to move this aside to get to that screw on either side.
So you kind of have to split that to get to the screw.
Yeah, so that just
so you
gently
and it's a
push
flat
those
head.
away.
You got to push these really
Yes.
delicate wires out of the
Yes.
way on both sides to
Yes.
take out this tiny.
Yeah. And that's usually how you can tell it's never been taken apart. All the wires look just like that from the factory.
Gotcha. And that's how you get to the sides of the step.
they have
If
to
you,
be returned to that position, or will they?
No, they're fine just as long as they're out of the way. Yeah.
and then you have to get those other screws out as well.
yes. So there's
And then that
there's a
takes the
total
boards
of,
off.
Total of 8 screws, 4 on each side. So we'll gently move
There you
this
go.
dude.
And then they're just
And these screws are super easy,
super
to
tiny.
go flying.
Don't drop them on the
At
ground.
which point you get an immediate case of Tourette syndrome and start saying all kinds of nasty things.
There it is. See that tiny little screw right there?
Yeah.
All right. Gently rocking that open, and those rods come off.
Yeah, that pops
That
out.
slides out.
That
Actually
one
looks
was
pretty
locked
good.
in on the inside.
Yeah, that one looks pretty good actually. Not much in the way of.
So I don't think Chris got all the way down into that.
Yeah, there's a little burn on that one. You can see
Burn on the entrance
On the
there.
entrance, right. And there's one more status. There's one more little.
Oh, and then these are like little peak I think those are solid peak or peak coated screws. Solid peak screws. So probably the easiest thing in the world to strip.
You got it.
So go
And they're
slow.
Phillips. Use a teeny tiny Phillips.
So a tiny
head.
Phillips head to take out a literal plastic screw.
Yes.
So the whole screw has to be insulated
Yep.
because it is holding that center
Yeah, that little
focusing
the
ring on there.
gateway arch or whatever you want to call it.
You call a thing like that. Yep. And then it sounds like there's like a whole ring of pogo pins that connect this thing together.
There are.
Which it scares me. Scares me.
It scares all of us. Not gonna lie.
All right. And
Actually,
then he's just
we have
using
very
some
few
needle nose
problems.
to pull those out, so we don't have any problems with these guys losing a thread at the end.
And then just kind of be gentle with this. Make
Yep.
sure it pops off the stainless.
Yep.
You
Kind
rip
of
the
rock it
wires
back and
off.
forth
Yeah,
and make sure you don't
Boom,
force
there you
it.
go. And so I'll put this also. I'll take these little peak things off.
Yep.
Put that in with all of the stainless stuff so we can acid wash that.
And then this you just set in. You're not dangling it in midair or anything
No,
like that?
usually what I'll do is just set it in the beaker along with this, set them side by side in there.
Gotcha.
And like I said, hit them with the MS cleaning solution. That stuff actually works quite
So
well.
the only thing that's a no-go on boards is acid. So if you have to go methanol water, that's fine, but don't do acid.
Correct.
Solution
Kind of like a dental tool.
Isopropanol, methanol water.
It's a surfactant of some kind. I
Oh.
don't know specific. You'll see it's bubbly and has a very distinct smell, and it actually works very well. The whole key is whatever you
see
put
how it
on,
works.
you have to get off. And you can even rinse it in just tap water. Just rinse.
You can't have any iron carrying contaminants.
100%. Because I've seen that happen, and invariably you'll put it all back together, and you're charging off and be fun to break. Not bad.
Popping apart.
Easy enough.
To get to the source block heater. Source block heater is just a few screws.
Just one screw, actually.
One screw,
Yeah.
ceramic plate, and then we're going to take out the whatever it is, the isolation valve there.
Yep. Going to isolate the isolation valve.
Yep. Again, so just that one screw on the right,
Yep.
and then with the needle nose, just kind of give it a wiggle and not force
Give
it
it a
until it
little-
comes out.
Wiggle, sniggle, and hopefully
Yep.
that'll pull right out.
Very nice. All right, so there's the contacts right there, and that thing's out.
It
And
is.
then,
Pull this O-ring.
yep, pull all the O-rings except for the PTFE
That
coated.
one's PTFE coated.
gas
It's not going to
line
be a
there.
problem. Yeah, that's for your cone gas, right?
And remember, there's that little divot there, so you don't have to actually, jab at
Dig.
your
You
O-ring.
don't have to dig too hard.
Sometimes roll a glove across them and they come out, but yeah, that's pretty
All right,
nice.
there's that.
And then this guy just literally pulls out because he's got an O-ring holding him.
Yep. That what I'll normally do is just get a little bit of Formic,
Just wipe
or
it.
something, and just put a Q-tip through it.
Gotcha.
Yeah.
Okay.
And that's good. There you go.
There it is. There's the whole block.
There it is. In a
And then,
nutshell.
so we're not taking off any of this insulation.
No.
You're going to leave all that on there.
Correct. The only other thing I'm going to take off is this O-ring right
That O-ring there on that middle portion.
on the back side.
They call it a funnel, but it's not a funnel. So it's like
It's an
entrance.
aperture.
Yeah,
basically
aperture.
It's
Just the hole.
exit aperture. It's in a hole. It's in a hole.
It's not a lot of fancy words for that one.
No, it's really not.
But it does hold the two pieces of the StepWave together at the proper height and things like that. And
Yeah, exactly.
Yep.
So
All right, so now this is all ready to go.
that's about it.
Perfect. All right, so we're going to sonication here. We got the source block and all the metal going over into this beaker here. We're doing the 1 liter beakers. And that one's going to go straight formic acid. 100% clean formic acid, is that correct?
Correct.
And then we're going to sonicate that for, 15, 20 minutes.
Yeah, sounds
Get it all
about
clean. And then we're going to replace it with clean water. Double deionized 18.2 mega ohm water.
Got it.
And, yep. And then we'll do methanol after that and then make sure it's all dry. And then the StepWave pieces are going to just kind of balance in here.
They are.
And they are going to go into the proprietary Waters source cleaning solution.
You have no idea.
The
proprietary.
The amount of I wouldn't dare mass spec that stuff and figure out exactly what's in it.
The proprietariness is off.
But it is essentially a surfactant that's going to be in there, and the surfactant needs to be removed completely by flushing it with tons and tons of water. But again, on these pieces here, no acid or corrosive, so that's why we're using the detergent-based proprietary cleaning solution.
Or anything like that.
Yeah, so we got the RF MS1 generator, and then I'm gonna come on to the top. Maybe I should stand up on a chair on the back here. Yeah, those are like really sensitive, right?
Yeah, talking about these, right? To pull the lid off, right?
4, 6, 8. Okay.
Yep. And you don't have to pull off the collision gas feed through anymore, like you do on the other ones. There's an actual little ring.
This is a vacuum gauge?
Yeah, that's one of the Piranis. So this is the Pirani for the back half of the StepWave. That's the Pirani for the collision cell.
When you take off that RF generator, you just kind of loosen it and pull it straight up? How
Yes.
much? It's just,
Yeah, so
it's a risky move here?
Not really. You basically just have little spring-loaded screws, one on either side.
Okay.
And normally, yeah, I should have done that, but because normally the lids have a little demarcation where you put it back down.
Yeah.
These, for whatever reason, do not, but basically I try to do it from above, and you just
Gotcha.
drop it
So-
down where it fits over. And
So it's harder to put it back on, so they kind of seat
a
in.
little tougher.
Yeah.
So that
This is a big chunk of metal that's going to have to come off all this thing, and so I'm guessing these are like these pull rods here, or something
Yep.
like that, to help you lift,
You got it.
hoist this giant chunk of steel, or aluminum.
Aluminium.
Aluminium, not steel, of course.
So basically, just give it a rock back and
So you
forth.
kind of rock back and forth. Because it is sucked down by the vacuum on these O-rings.
It's not messing around right now.
Yeah. Closed up while you're working on the rest of the instrument here. 2 electronic Pirani gauges.
There's also some
and then the
connectors that I
feed-throughs into
took
the
off.
quad.
There's 3. So there's one for the
Yep.
front half of the twig, or back half of the twig. Front
Yep.
half, well, it's not a TW, it's not a twig actually, but this is going to be for the collision cell.
Gotcha.
So, and then you've got also the pre-filters,
Yep.
which is that one. The collision cell ones are over here.
Yep.
And then one connection each for the RF generators.
And then you don't have to take this gas line off or any of those.
down there.
This whole plate comes off without the gas lines coming off, essentially,
Correct.
right?
Yeah, this is the first one to do that.
Yeah. And then you took all these screws out that are in there, and those are just screws with a washer?
Yes.
Okay.
They're sitting right in that little.
Okay, I see.
Right there.
Perfect.
Thing is trying to get all of this stuff so it's out of the way.
Oh, yeah, they really gave you some room to work here,
They
didn't
always
they?
do. Over here too. this
Yeah, and you
plate.
got that plate. It's just go slow, watch all the wires, and then the whole thing just pops right out. Isn't that beautiful?
Can I give it to you?
Yeah, of course. Hey, I hand it over here. We got this guy out, and he stands on his nice little feet. And then look at this beautiful guy right here. All right, so walk me through what we got. So we were coming in. This is the back of the quad assembly, and so this is the front of the quad assembly here. And look at that soldering job, guys. Look at that copper soldering. We aren't messing around with no skinny copper wires.
No.
No tiny little quads. What are these, like molybdenum or something like that?
molybdenum.
They're made of that molybdenum and copper. And they're called quads because there's 4 rods. That's pretty obvious. So what's the octopole on the outside, though? Is there just like the fact that there's an extra one there to help
Basically,
with
it's just to keep everything aligned.
keep everything aligned? We got a little bit of extra external
You got it.
plate there. Very, very nice. I'll say it again. Maybe I'm being nitpicky, but if you look at this pole on the quad here, on the end of the quad, and you look at the pole here on the front of the quad, it's not as shiny.
Oh boy.
I would assume they'd want to have an equal amount of shininess,
Shininess.
and that amount of lack of shininess on molybdenum would be a problem, and that is why we are cleaning this front quadrupole. Are you going to clean the back quadrupole or just the front?
Both.
Both.
Yeah, we'll take a look to see how nasty they truly are.
Yeah, I'd like to know if that's actually a legit amount of dirtiness.
Oh, I suspect you're going to see dirtiness probably the likes you've not seen.
Oh my goodness.
That's just a guess.
It's going to be dirty.
You hear momentarily what we're looking for.
Here's our tools. Pretty simple. Using, again, the needle nose to disconnect electrical contacts.
There's
two little electrical contacts.
Yeah, these are cambium pins.
Yes, you see.
Cambiums.
In the center cambium pin there, you leave that one because that's on the board itself.
That's on this one,
that's
right?
on the actual metal plate itself. So just
this is the application to your for your RF. Actually.
Yep, that's the RF.
I'm sorry, not RF. This is for your pre and post filter.
Gotcha.
Yeah.
So disconnect both the left and the right.
Yep. And
side, but leave the center.
A 5mm deep nut driver.
5mm deep nut.
Get these off.
That's so they can make it all the way through all that tangle of wires.
Again, do not lose these.
Don't drop
there
screws.
Are no replacements. They're nuts. Yeah.
And then there's a washer on these, or
there is. Yep.
There's one.
So there's
fell
one.
off, and they are tiny.
They are teeny tiny. Yep. So that goes there, and I try to keep all this stuff together. So just one washer that we're concerned about. Just maybe.
Got it. Okay, so take those out.
Smart
now we're just doing the other side, and again, watch out for losing these guys.
Yep. Usually they just fall down on here, and you can retrieve them with the needle nose or hemostats or however you want to do it.
Well, I think normally you're.
Alright, so now we're taking off these 4 screws or nuts on top, and again with the washers, and they're different size.
Yeah, different. So these are 7mm.
Them.
These are 7, and then we also have some 5.5 millimeters.
Oh man, so we got 7mm, 5mm, and 5.5. So you got to have all of them here.
The ground, it's the same.
So
one.
same ground. So again, careful. That's where the ground goes.
Yep.
And is there an extra washer on the ground ones?
There is not. It's the same.
Same, okay.
Same washer and lock washer package.
Good.
So yeah, everything in this is identical to the TQS and TQXS.
Okay.
With the exception of
the center,
the collision cell.
Gotcha.
What's the difference?
So the collision cell on the previous two that I mentioned. They have a technology called ScanWave technology. I don't know if you probably know about ScanWave. So basically what it is in the very back end of the collision cell, before you're going into MS2, you can actually put a barrier up and collect ions of a specific mass so that you can basically
dwell them a little bit.
Yeah, so you hold these almost like an ion trap situation. You put up an RF barrier.
It's not like a C trap, but it just puts an RF barrier gate around it essentially, and then unloads it on a wave.
You got it, and that's exactly what it does. So
that's cool.
This does not have that because nobody actually uses it.
Because nobody needs extra sensitivity on an ion, really.
When you're getting to this level, you really kind of don't, especially on this thing in negative ion.
Plus, it speeds it up probably, right? So you don't have that option. You can just run it as fast as possible.
Yeah, and that's another thing too. Is the TQXS and the TQ Absolute have a little bit different scan rate. So it's super highly elevated. So that's another good.
So now we're just undoing these completely, and then make sure that you know which one's which, and they're numbered and they're in the right order.
That's the way my mind works.
Yes, no, that's smart.
I will show. So this is the trickiest part of the whole thing is putting this back in. Getting it out of the cradle is no big deal. You just make sure that you lift straight up, otherwise you'll break the ceramics.
Okay, so straight up.
Right, what you will see...
And the whole cage pops out.
That little notch right there has to go
into that pin.
And getting it back in there can be maddening.
Okay.
It will drive
and then these seat back down onto the base plate there?
Yes, so it'll seat back into this cradle.
Yeah.
But like I said, that one's got the little nipple that sticks up.
Yeah.
And it fits right in that little hole right there.
How do you know the front and back? I guess you just know from the connector pins, essentially.
Right, so you see the way that it fits on.
Yeah.
So, and these quads are completely...
those wires on the front...
interchangeable.
Yep.
If you were to change quads out, the only thing you would need to do is move these wires over to here. So you change you can see that's the only real difference. It changes the position of that.
Gotcha.
But other than that, it's however, let's see it. Yeah. Oh my goodness. Okay. So, do you have a flashlight that you can shine? Okay. So if you look, let me see. I just saw you. Where are you now? Sorry. If you look on this rod down in there, you'll see what looks like a little lightning bolt in there, and it's about 1/4 of an inch long. It's kind of purplish.
Okay.
Here, let me grab a. You out of the way.
Yeah.
A little more workspace here. Okay, you can set these on the ends. Take a look in there, and you'll see it on opposing rods if you look closely. And it basically is a looks like a little lightning bolt, and it's ion burn is what it is.
Okay.
And my guess is you'll probably be able to see that all the way
Oh,
through on
what
both.
you're saying is that's not like something Waters has engineered on there.
No, this is dirty.
As a label.
Right.
Maybe it's not visible to the naked eye, but there should be an iron burn.
If we look, yeah. So it's hard to see. Gosh dang it! I don't have a pin light. So you have the light on there? Okay.
Yeah.
So let's see. If you look down there, and it really is difficult to see in this light.
okay.
See that little burn? It's on this rod right here.
Okay.
It's on that rod. And if you look down there, you'll see a burn. So if you... Where are you? Oh, man. It's on this rod. So there it is. Right there.
I see it.
See that bugger?
A little right there, right down the
You
center.
got it. You
I see
got
that
it.
little bit of
That
dirt.
is classic ion burn right
All
there,
right,
and
wow.
that's a chunk of it right there.
That's a chunk
So
of
you will
stuff.
see that on opposing rods.
Okay. All right.
Yeah, and as soon as you missed everything.
Oh my.
So like I was
all
telling
right.
these guys, I like to push down
Okay.
on the pre-filter or post-filter so that you don't put any strain on the little ceramic
This is
rod.
the 5.5 that we're using now?
5.5. This
Yep.
is the 5.5. Yeah. So if you lose one of those 5 millimeters and try to put the 5.5 on there, guess what?
Yeah.
It doesn't work. And there's
And then you're just kind of disconnecting this whole cage.
Yeah, just taking the cage one little bit at a time.
With the washers, and keep these guys separated because they're definitely slightly different in size.
Yeah. Okay.
And then you can kind of bend those out of the way.
Yes, you can. Now we'll take the 1.5, and I don't like to use the ball end because if you strip this thing out, it makes life
And
no
these
fun.
These are just set screws.
Yep, little grubby
With the
screws.
1.5.
Yep. Just give it. Yeah, sometimes they don't line up well. We can fix your little red wagon.
Oh yeah, those are really in there.
They can be in there. Okay, so now you see.
Okay, so now that
So when you take these things off, I highly recommend turning it upside down so that everything comes out with it. And what you don't want to lose is see that little. So you got a little ceramic spacer right under that little copper spring.
Yes, there's
right
a little
underneath
copper
there.
tension spring
Yeah,
in there.
you don't want to mess with that.
Okay.
That's no way
So
to have
all
fun.
these heads are going to pop off the same way on the pre-filter here.
Yep. And the post.
And the
so
post filter. So you take off the pre-filter and the post filter on each.
Yeah.
On each
So
one.
I will do one set, clean it.
It doesn't matter which.
Put
doesn't
it
matter
all
which
back
quad
together.
has which,
It
right?
doesn't
So
matter,
you're just
nope.
going to keep them all separated.
Correct.
Yeah.
Yeah.
But it doesn't matter which pole goes to which pole.
No.
They're all identical.
All identical, yeah. It's just
Okay.
these are all the difference. These are stainless steel. That's the only
Gotcha.
difference. These are molybdenum.
Gotcha.
But I'll do one side, do all the cleaning, put everything
And there's
back,
no difference
then
between
flip it over.
and there's no difference to the front and back, or that you make sure the front goes to the back, but
There is no difference though. They're
gotcha.
identical.
All right. These guys are off.
Good look at the. See that burn?
At
Now
the
you can see
burn.
mark right there. Now you can see it.
That's our Harry
Right there.
Potter.
There you go.
That's a dandy, and then you can see the opposing rod has the same burn.
I can see it there. The nice line.
Yep. It's a triangle, right? You see the triangle? Yeah.
Yep.
That's classic. Abrasive.
So we're going to use the Crest
It
White
doesn't
Arctic
even- it doesn't
Fresh
matter.
toothpaste, but
Doesn't
any
matter what
toothpaste
kind.
works.
Yeah. This is
And
blue.
the blue one, so you know you
Doesn't
got it
matter.
all off.
Doesn't matter.
So we're not liking silicon oxide powders. We're not liking lapping films to clean these quad
And all I do
poles.
is I make a little slurry with toothpaste and water.
And then just use like a toothpaste toothbrush to scrub it on, or what do you use to scrub it on?
So, if you ever want to get rich,
Oh, it's these Q-tips.
go into the Q-tip business.
Yeah, they use a lot of them, and they're all.
Well, the funny thing about these is you can get 1,000 of them for like $5.
Yeah.
So probably not the way to get rich, actually. When I
But you do go through a lot of Q-tips. I do those as well. And so you just kind of rub the cotton swab Q-tip around the whole thing, essentially. All right, there we go. Easy enough.
Let me clean these out a little bit.
Very good.
Get going.
So this is as far as it comes apart. We have it all taken apart. The stainless steel tips are off. The molybdenum stays in place.
Yep.
All the insulators, all of the poles, nothing else goes further than here.
Nope.
We're just going to use long Q-tips in the slurry of toothpaste and water, just to clean the char off the inner edges of the poles and get rid of all that star pattern.
Then water.
And then water, and we're just going to continue cleaning with Q-tips, with water and methanol.
And then the last thing is the DCM to
And
get
then-
off any streaks
and
that
then-
methanol might leave.
Then DCM as well at the end to get rid of all the streaks. But we're not going to dip this thing, right?
No.
And we're not going to do anything other than clean it with these Q-tips. So just, get it really clean and get all the different solutions off. Final cleans with DCM. All right, so we just took this board off, just the 4 screws, and there's a ground wire on each side. You can see it's connected right there to that position there. So you got to take those ground wires out. And then this is color-coded green and red for the plugs, so it should be pretty easy to know where it goes. Just keep track of which plug goes where. Take that thing out. And now we have cleaned. We just cleaned with the different solutions here. We got dilutes, toothpaste, and water. We got plain water, and then we have. Oh, is this methanol?
Plain, just toothpaste slurry, plain water, methanol.
Methanol. Gotcha. And then the DCM, you do DCM as well?
I do that last.
Do that at
You
the
can leave
very
everything
end. So
all
leave
back
everything together, and then you do the DCM.
Yes.
And then we put on those pre-rod there, and tighten it all back together.
Take this off. We're doing the other side.
Now we're doing the other side.
Yep.
Very good. And by other side, we don't mean the other quad. We mean the other side of that quad. So you're going to have to do this a total of, gosh, what is that, 16 times here.
Too many times.
Too many times. It's not an octopole.
That's okay.
So we got the front quad back in, and then we've removed the back quad the same way, and we've taken the caps off the same way, and then cleaned it the same way.
Yep.
And now we're reassembling it back with the washers and the nuts, and it's all put back together. You still have to do the other side, or it's completely done?
It's done.
Man, you're a fast quad cleaner. Fastest quad cleaner in the West.
Right?
Because he's the Western Territory. And then you inspect it by eyeball. Then the last wipe down was with a Q-tip with the DCM.
We already did that.
Already did that.
Yep. So we're going to blow it out with some clean dry nitrogen.
Hey, how's it going, man?
Felix was kind enough to set up for
Yeah, very good. All right, and then we'll show you guys how to put this in.
And a significant amount of stock and some fastener.
Some sort of I got to be making them themselves, machining them out of aluminum.
I would assume.
So we're taking every single one of these. I'm assuming there's just T5 regular screws here.
Yep.
Out of this inner quad. So it's a triple quad. There are 2 quads, and then a middle kind of a quad. I think they just like calling it a triple quad because it sounds sleek, because the middle quad is kind of not really a quad.
It's not really a quad.
It's not really a quad. It doesn't look like the other quads, and it is the collision cell. So the quadrupoles on the front and the back are isolating either your parent or your daughter ion, so you can send those just through. They're like a gate, a filter. And then this looks a lot more like a lensing stack, kind of like the front end StepWave.
More like this is what we call a twig, traveling wave ion guide.
Traveling wave ion guide, and if you put one of these inside of a gas-filled cell, you would have a ion mobility cell, essentially.
Very similar, yeah.
Very similar in technology, because you would still have the traveling wave. You would just have a countercurrent gas and a bit of ambient gas. What a tricky little booger, and lots of gold plates and lots of fragileness, so you just got to move slowly.
Lots of fragility.
And then you can take this faceplate off. Success, there it is. You know, it is a printed circuit with a bunch of golden pins and plates, and so you just kind of wiggle it.
There it is.
There it is. Does this thing get that dirty, or how do we clean that? Same as the other circuit boards, essentially?
It's going to get dunked, yeah.
Dunked, and so it goes into the MS cleaning solution. Again, no acids or corrosives on that guy.
No, sir.
And anytime you see printed circuits and gold plates, you're just going to do that MS cleaning solution detergent.
Or if you're in a pinch,
methanol water. Yep.
Right.
Now we're dropping this thing back in. Again, you got to make sure you get it straight down, and then that notch is in the front, closest to the collision cell, and then just drops right in.
How about that?
That's good looking.
Yeah, it made it.
Placement, everything screwed back together.
Wow, you can drop a quad on the first time, it's probably your day.
It is really good. And so now it is all these tiny washers and screws.
Yep.
Just like before on every single one of these copper connections. And then you're going to have to plug your 2 wires in there. And that's about it. Yeah, after you got those bolted in, we're going to put the cradles back on the top of that aluminum housing with the ground and its washer first. And then tighten those guys all back down.
You got it.
But since we have all of our screws and there are various piles all organized, it just comes right back together, this thing.
Well, theoretically.
Hopefully it behaves.
You always find one screw at the end. You're like, where'd that guy go?
Yeah, hopefully not.
Hopefully not.
So far, so good.
So far, we got all the screws.
Yeah, so far, so good.
All right. So reassembling nothing really serious other than putting the heater in for the source block there. And then sliding back together the StepWave assembly. Probably a few more tricks will show for that on how to get the attachment correct.
Okay.
But yeah, source block, pretty straightforward. Just put things back where they were.
You got it.
Yep. You want to put those guys seated in first. They screw in.
They do.
Those are the ones that we started with the dental tool.
Yeah.
So just watch this video in reverse, taking things apart, and put it back together in that order.
Go. Now we can go back.
Now they're back on, and it sits again in that little notch. And then same thing on the other side.
So what I typically do first, set it on its nose like that.
Okay.
And I put these 2 dudes in place.
Gonna rest those rods in place.
Hope that this is going to be good to me and line up reasonably well.
Okay, and then we're just kind of hoping that those wobbly pins kind of
they're a bit of a pain, but we'll get them.
Gotcha. Let's take time.
Sorry, I just jumped back here after looking at Ben's thing.
It's not good news over there.
Basically lost his motor step. I even went into calibrating it, it accepted it. Right after that, it just said, I don't know where.
I'm sure there's a better way to do this. I'm just not smart enough to know what that is. There we go.
Now,
Perfect.
if I give you
Boom.
Boom.
first of all, you have to
There it is.
Okay. So next we'll put those.
So once you have that in, you put those tiny little peak screws in.
You got it.
Peak screws have to be on there. Those are those really tiny guys. Be very careful.
Yep.
The peak screws are in, not even a problem. We're on the complicated bundle of wires plus flathead screwdriver maneuver.
Yes.
And
We got
that
pretty well
is
done.
back in.
I'm going to let Calvin do the rest of this.
Yeah.
you believe, trust me.
There we go. Look at that. Alright, StepWave back in with the StepWave tool here. Just put it into the tool first and then push it in.
The key is make sure you use that to seat it the last.
The last bit when you push it in so you get the right distance.
With the heel of your hand, like you're trying to push the instrument off the.
Yeah, gotcha. Alright, so this is pretty cool. From the back of the instrument now, since the quad assembly is still out, the StepWave and the focusing lenses are all back in, you can see that exit there where the ions come out and go into the quad assembly. And so that's we push that in from the front source. So that's the back of the StepWave assembly right there. And it wasn't even recording it here. Wasn't even recording. All right, so you got to get these two plates lined up snugly on the collision cell. Flush is the key.
Flush is
And then you're going to put your wires back on and all your screws, million screws back in.
Yep.
Reassemble this whole thing like you took it apart.
Correcto.
And then back in. Got the front source closure on and everything's ready to go on the front. Drop this guy back into all of your screws. Reconnect a few of the gauges and the different things disconnected. And you're good to go. Yeah.